Hello my dear friends, my name is Vigyan Tiwari, working as an assistant professor at SITS Bhopal. So today we are going to see how to remove epsilon moves from finite automata. So this is the question which we are going to solve today. So suppose we want to replace our epsilon move from vertex q0 to q1. Okay, so then we proceed as follows. So try to understand the rules. Find all the edges. The first rule says find all the edges starting from vertex q1. So we'll have to identify all the edges which is starting from q1. So these are the two edges. This is the first one and this is the second one, which is starting from q1 itself. The second rule says that duplicate all these edges. We'll have to duplicate all these edges starting from q0 without changing the edge labels. So we'll have to duplicate. Let's try to understand this one. So we'll have to duplicate all the edges from q0. Okay, so these are the two edges we have identified. So we'll have to duplicate one from here to here for what value? For epsilon, and one will go here itself at q1 itself, starting from q1 and goes to q1 itself. So we'll take a node from here itself for what value? For 1, because the second rule says duplicate all these edges starting from q0 without changing the edge labels. So edge label is not changed. Edge label is not changed. Okay, and the third rule says if q0 is an initial state, make q1 also as an initial state. Okay, so we'll have to make this also an initial state if this is an initial state. And last rule says if q1 is final state, make q0 also as the final state. So here it is not applicable because this is 1. Definitely it is going to applicable here itself in this two nodes, that is in q1, in between q1 and q2. Okay, so remember these 4 rules we are going to apply in this problem itself. We'll see. So these are the 4 rules. Okay, hope you have understood that rule, and I am going to apply here. So let me draw this one. So this is what we have, this q0, and we have this q1. Again we have this q1, and again we have this is a final node, and that will become q2. So first of all I will try to remove the epsilon from q0 and q1. So in between these two nodes I am trying to eliminate the epsilon. So the first rule says what? We'll have to identify the duplicate edges. This is the duplicate. So we'll have to find what? All the edges starting from q1. So these are the edges which is starting from q1. So we have identified successfully, and duplicate, we are going to duplicate all these edges from q0 itself. Okay, so this is from q1 goes to q2, so that's why we took this one, this line, and the edge label will remain same. So we are going to duplicate the edges. So for epsilon we have a transition from q1 to q2, and that's why we made from. So what we are doing here, we are trying to eliminate epsilon from this q0 to q1. Okay, so that's why we have done this one. And again we have a node here itself, that is for 1, that is going here itself. This is for 1. So we'll have to duplicate again the edge from here itself, that is for 1. Okay, so this is what we have, and everything will remain same. That is, this is 0, and this is for 1, and this is for 2. That is what we have right now. Now try to understand, this is the third point says this is an initial state, so we'll have to make this Q1 also an initial state. We made it. This is the 4 rule says this, if this is final, then we'll have to make this final also. So this is not applicable here. So this is how we are going, we have applied this 4 rules here. Okay. Now again we'll have to eliminate epsilon from Q0 to Q2, because epsilon is eliminated from here itself, but it is present right now here. So we'll have to eliminate again. Okay. So let's try to understand again what we are going to do. So what we have here, Q0 to Q2. So how many edges are going outside from this Q2? I will have to identify. So we have only one edge. This is for 2 here itself. Okay. So we'll duplicate one edge from Q0 to Q2 for a 2 itself. Okay. So this will remain same. Now we are eliminating the epsilon from between Q0 to Q2. So we have, this is Q1, this is 1. This is again what we have, 1 here. We have an epsilon move here also. This is final. And try to understand. This is 2 is already given. So we are trying to eliminate from here to here itself. So there is only one edge, that is 2. So we'll have to duplicate this edge label from Q0 to Q2 itself. For what? Without changing the edge label is 2. So we will do this one. See, epsilon is get eliminated from here itself also. So what will happen? This is definitely, this is Q0. So what we have, if this is initial, we'll have to make this initial also. So this is a final, so we'll have to make this final also. See? Okay. Now we'll have to eliminate epsilon from Q1 to Q2. Again we are going to follow that 4 rules. So right now what we have Q0. Here we have 0. So this is the way through which we can eliminate epsilon between 2 nodes or 2 vertices. So we have this, see, here we have already. So initial is also there. Okay, don't forget it. So we have initial state here itself, and this will become final here itself. So we'll have to make this final also. So this is final also. Now see, we want to eliminate this epsilon from Q1 to Q2. So what we'll have to identify the edge label from Q2, that is only 2. So we'll have to duplicate from here to there. So from Q1 to Q2, we'll have to duplicate the edge label. That is what? That is 2 and nothing else. And 2 is there itself. That's all. This is already there for 2, and this will become initial also. So we have arrow mark. So this is a representation for that initial state. Okay. And now see, if this is initial, we'll have to make this initial. If this is final, we'll have to make this is also final. So Q1 is also become a final state. So this is the way through which we can remove epsilon from a given FA. So we will start removing this epsilon between 2 nodes. So we'll consider 2 nodes and we'll try to eliminate the epsilon. Again we are going to consider 2 nodes and we'll eliminate the epsilon. Again we have considered this 2 node and we'll remove the epsilon successfully from the whole FA. So this is the FA which is not having any kind of epsilon move. Okay. So thank you. Hope you have understood this one. Thanks for watching this video.